Imagine your headphones connecting instantly the moment you put them on, your smartwatch syncing health data without you lifting a finger, and your car unlocking just because your phone is nearby. No wires, no waiting, just a silent handshake between devices. That invisible connection is Bluetooth, and it's running billions of times a day all over the world. But have you ever wondered how it actually works? How two devices find each other in a sea of signals? Or how your data isn't stolen midair? Today, we're diving deep into the science, the magic, and the security that makes Bluetooth possible. The basics. What Bluetooth really is. Bluetooth is a short-range, wireless communication technology designed to replace cables between devices. It uses radio waves in the 2.4 GHz ISM band, which is an unlicensed frequency range also shared by Wi-Fi, cordless phones, and even microwaves. Unlike Wi-Fi, Bluetooth is optimized for low power consumption and short distances, typically up to 10 meters for most devices, although some high-power versions can reach up to 100 meters under ideal conditions. What makes Bluetooth so efficient for close-range communication is its ability to create a secure personal area network between devices. The technology operates using a method called frequency hopping spread spectrum, meaning it rapidly changes its transmitting frequency up to 1/600 times per second across 79 available channels. This not only reduces interference from other wireless devices, but also adds a security layer, making it much harder for an eavesdropper to intercept the connection. Pairing. How devices find and trust each other. When you connect two Bluetooth devices, pairing is the process that establishes that connection. It begins with discovery, where one device enters discoverable mode and sends out a signal announcing its presence. Another device, in scan mode, listens for these signals and responds when it detects them. Once the devices recognize each other, they move into link establishment, exchanging identification data such as their unique Bluetooth address and the profiles they support. A profile is essentially a set of rules and capabilities, like whether the device can stream audio, send files, or act as a keyboard. Authentication and key exchange then take place, ensuring that the devices trust each other. This stage creates a shared secret between them, which is crucial for secure communication. Depending on the devices and the Bluetooth version, this may involve entering a PIN, confirming a displayed number, or simply tapping to confirm. The devices then store this information in a bonding process so that the next time you connect them, they can skip most of the pairing steps and link instantly. Different pairing methods. Bluetooth has evolved through several pairing methods over the years. Early versions used legacy pairing, where users manually entered a PIN code on one or both devices. This method worked but wasn't very secure, as the PIN was often short and predictable. Starting with Bluetooth 2.1, secure simple pairing became the standard. This system uses elliptic curve Diffie-Hellman public key cryptography to securely generate shared keys without sending them directly over the air. It includes modes such as Just Works, which skips user input but offers minimal protection. Numeric comparison, where users verify matching codes on both devices. Passkey entry, where a code is typed from one device into another. And out-of-band pairing, which uses another communication channel like NFC to securely exchange keys. How Bluetooth transmits data. Once paired, Bluetooth devices communicate by sending small packets of data over radio waves. Each packet contains both the actual data and metadata for routing and error checking. Bluetooth traditionally uses a master-slave communication model, with one device controlling the timing and the other following. In modern Bluetooth low-energy systems, these roles are called central and peripheral. The data transmission process is fast and flexible. By hopping frequencies constantly, Bluetooth avoids crowded channels and maintains a stable connection, even in environments full of wireless signals. Security. Protecting your data. Bluetooth includes several built-in security measures. Authentication ensures that the device you're connecting to is the one you intended. Authorization determines what actions a connected device can perform. Encryption scrambles the data so that anyone intercepting it cannot read it without the correct key. Modern Bluetooth typically uses 128-bit AES encryption, and the encryption keys are generated during the pairing process without being transmitted in plain text. This means that even if someone captured every bit of data sent between your phone and wireless speaker, they couldn't decode it without having already been part of the secure pairing handshake. Potential security risks. Despite strong protections, Bluetooth has faced various security challenges over the years. Bluejacking is when someone sends unsolicited messages to another Bluetooth device, more of a nuisance than a threat. Bluesnarfing is a more serious attack where data can be stolen without permission if a device's security is weak. Bluebugging allows an attacker to take control of a device, potentially making calls or sending messages. Many of these attacks have been addressed in newer Bluetooth versions, but they highlight why users should only pair devices in trusted environments and keep their firmware updated. Bluetooth Low Energy (BLE). The Power Saver. Introduced in Bluetooth 4.0, BLE is designed for devices that need to run on small batteries for long periods, like fitness trackers and medical sensors. BLE reduces power consumption by sending data in short bursts instead of maintaining a continuous connection. It still offers strong security, including LE secure connections, which use advanced cryptography to keep data safe even with lower energy use. Frequency hopping. Bluetooth's invisible defense. Frequency hopping is one of the most important features of Bluetooth security and reliability. By rapidly switching frequencies in a pattern known only to the connected devices, Bluetooth avoids interference and makes it extremely difficult for attackers to track or intercept the data stream. An attacker would need to know the exact hopping sequence and keep up with the rapid changes, which is practically impossible without already having access to the devices. Bluetooth profiles, the language of connections. Bluetooth works because devices agree on a common language for specific tasks. These are called profiles. For example, the Advanced Audio Distribution Profile handles high-quality audio streaming. The hands-free profile is used for in-car calling and voice assistance. The Human Interface Device Profile supports keyboards and mice. And the Phone Book Access Profile allows your car's infotainment system to read your contacts. Without matching profiles, two devices might connect but be unable to function as intended. Pairing in the real world. Step-by-step example. Imagine pairing your phone with wireless headphones. The headphones are switched on in pairing mode, broadcasting a signal. Your phone, scanning for nearby devices, detects the headphones and shows their name. When you select them, both devices exchange identity information and perform a secure key exchange using elliptic curve cryptography. A shared secret is generated without being transmitted directly, and this secret is used to encrypt all communication between the devices. The next time you turn on the headphones, your phone will connect to them automatically without repeating the full pairing process. Future of Bluetooth. Bluetooth technology continues to evolve. Newer versions like Bluetooth 5.3 offer faster pairing, lower latency, and improved efficiency. Developments in location accuracy, multi-device audio streaming, and power management will make Bluetooth even more central to everyday technology. Imagine audio seamlessly switching between your phone, laptop, and TV, or indoor navigation systems guiding you with centimeter-level accuracy, all without wires or manual connections. Why it matters. Bluetooth isn't just about convenience. It has become an essential part of modern life, linking devices in homes, workplaces, hospitals, factories, and cars. From medical devices that send vital health data to industrial sensors monitoring equipment, Bluetooth is silently keeping the digital world connected. Understanding how it works helps you use it more effectively and securely. So the next time your earbuds connect instantly, remember that behind that simple pop-up is a sophisticated process of discovery, authentication, encryption, and rapid frequency changes happening thousands of times a second. Bluetooth isn't magic, it's engineering brilliance. And now you know exactly how that invisible handshake works.